Right, so we're told in this question that all the forces are in equilibrium, in other words, they're balanced, okay? So it's not moving, this particle here, all right, where the force is acting on this particle, this point. There's no movement at all because they're all balancing each other out, okay? So what we do is we do a force diagram, and I always have like an x-axis and a y-axis. I'll have all my forces along the x-axis and then my y-axis. So you see straight away here on my x-axis I can have 6 going in that direction and p going in the opposite direction on my x-axis. On my y-axis then I've got my q going this way, okay, and there's nothing going this way at the moment. Now the problem we've got is this force here, right, this 8 Newton force, because it's been applied, this force, at an angle of 60 degrees, okay, and what that means is there's going to be sort of a movement for this force in the sort of x and the y direction, okay? It's going to have an influence, rather, maybe that's a better word. It's going to have an influence on the x direction and y direction. In other words, if you pull this way, okay, if you pull this way, you're going to go in the x direction and you're going to go in the y direction, and you're going to go in both directions when you go along this way, okay? So when we resolve in terms of x and y components, right, we need to appreciate that this 9 Newton force here will have a component in the x direction and have a component of force in the y direction, okay? And we can establish what those values actually are, okay, by just thinking about what this force here creates at an angle of 60 degrees simply by drawing a triangle, okay? So if I draw a triangle by the side here, okay, and represent that force there of 9 newtons, okay, as if it's obviously it'd be my hypotenuse of the triangle, okay, creating then an angle 60 degrees as it is there, okay, and this force here will be 9 newtons, okay. Now that would be like the hypotenuse, as I said, of the triangle. Now if we think about trigonometry, right, and so Cartoa, this obviously would be the opposite side, opposite of that angle, okay. This would be my hypotenuse and then my adjacent then next to the angles, all right. And I can figure out what the x component is going to be of this force just by working out what this side is, okay. And similarly I can work out what the y component of this force is by working out the O value here, okay. And I do that simply by, first of all then, let's focus on this side. So we look at the A, and of course with SOHCAHTOA, okay, the A involved here will be the cos, okay. So we've got cos 60 will equal the adjacent, okay, over the hypotenuse, which is 9, okay. And then of course to get A, you would just take that 9 up, wouldn't you? So you'd end up having 9 cos 60. That's what A would be if you take the value 9 up here and multiply. So I've actually got the component along this direction here. I've worked out what A is, yeah, which is this side here. So that'll be 9 cos 60. All right. Now similarly, I can work out what O is, right? To work out what O is, I'd have to use the sign, wouldn't I? Yeah. O over H. So I'm going to write it over here. Sine 60 would equal the opposite over H, which of course is 9. And then to get the opposite, I take the 9 up, so I get 9 sine 60 equals to O, right? So that's what would be on this side here, 9 sine 60. So in terms of resolving my forces, I will have 9 cos 60 going in the x direction, and then 9 sine 60 going in the vertical y, in that direction. Now, I've got to be careful not to use the word vertical because we're actually looking down on this, right? It's important to see that these forces are acting on a point, and it's as if you are like a drone looking down on it. So there's nothing vertical about it, okay? It's all horizontal, it's all on the ground. It's just that this is going in this direction, and then the y is going perpendicular to that x-axis, okay? Obviously it looks vertical, but we're looking down on this, yeah? It's important to remember that. So it says find the values of P and Q. Now of course, because it's in equilibrium, we can say, right, resolving in the x direction, that this here will equal this. So basically the sum of the forces going in one direction, of the x-axis so to speak, will equal the forces going in the opposite direction of the x. So we've got that. And straight away you can work out what P is. P will be 6 take away 9 cos 60. We get my calculator. And we get 1.5 exactly. And then to get Q, of course, then we look in the y direction. So the force going that way has got to equal the force going opposing it. So we get Q equals 9 sine 60. Of course, 9 sine 60 will be 9 root 3 upon 2. Make sure you put newtons as a unit. And we're done. We've answered the question. We worked out P and we worked out Q.